So we have gone through all these things. So yesterday we are telling about the some of the important concepts. So can anybody tell what are the things we have covered yesterday? Yeah. So today we'll be knowing about the data models. So how the data model is defined? It's a logical structure, very fast, and it has been processed and to be stored inside the system. So how I can define this one? It can be defined as a database model can be defined as how the data is connected to each other and how they are processed and stored inside the system. Now this is what the data model. In this model, we're going to tell about the something called important one is entity relationship model. Now, what is this entity relationship model? As I already explained about the what do you mean by entity. Entity is then an object that is existing in our real world. And although I have given the pictorial diagram that how it will be. So it is in the form of something like a rectangle. Okay. So a object in our database management entity is represented as a form of rectangle. So we are using this particular diagram for this particular entity. So it is a real world notation. So it's a real world notation entities and relationship among them. That means why the object has been identified. If it is identified, is any relation between the object. Okay. So how it will be? It will be based on the ER model. So in this, the more when I'm talking about the ER model, it is the important is entity and the relationship. Two things will be there. So when I'm telling about the entity has attributes and relationship among the attributes. So entities and their attributes. So attributes are nothing but their characteristics of the object. So object is existing to the object. What are the special characters? So entity is a rectangular box we are going to represent, and it will be having some attributes. Suppose here I am giving an example. Here I am given an example over here. So if I say this is an entity, this is a rectangle box. So here you can see this is an attribute. So oval shape. So oval shape, which you are able to see this one oval shape. Now this is an attribute. Now for the relationship, we are using the rhombus symbol. So this is a symbol which we are using for the relationship. So this is for the entity. So the object that is existing in our real world, this is an entity. So here if I say, if the entity is what, say suppose this is a student. So entity is a student over here. Is a student. Now when I'm saying another entity, I'll be saying something called college. So college is another entity. Okay. Now when I'm telling about the student attribute, so it can be something like roll number. So I will say roll number. It can be a name. Now here I'll be saying something called college ID. So it can be a college ID. And it can be a college address. Something like this. Okay. Then what is the relationship here? Relationship is that the student is going to study in the college. Okay. Or join the college. Join the college or study in the college. It can be anything. So here you can be saying that an entity is an ER model, a real world entity having properties. So here I said having properties, a real world entity. That means whatever that is existing in the world, it has some properties are called as attributes. Now in our case, Every attribute is defined by its sets of values. That means attribute has some values. Now here I am saying roll number is an attribute. What is the value for the attribute? Say 1506, 1501, 19143, 1506. Now this is the value of that particular attribute. So it has in a set of values. We call that as a domain. We call that as a domain. Suppose here I have been taken an example of student which is in a college. It is having the roll number. So roll number is 191431506. Is some of the student roll number. His name is Akhilesh. So Akhilesh is the attribute value which has been stored in the name attribute. So like this, we have different kinds of attributes and the entity. So entity is a real world entity which has the properties called attributes, and the attributes has set of values. Those values we called as a domains. Okay, now coming to the relationship. Now relationship is what? A logical association among the entities. So what is the logical association? This is connected to this. So student is connected to the college. So how it is connected? By saying he is studying in this or joining. So this is how it is been connected. That means this logically he has been connected to the other entity. So one entity is connected to another entity. We call that as a relationship. Now relationships can be mapped in the various ways. So different ways we can connect it. So how we are going to connect? With the help of the lines. Okay, with the help of a lines we are going to connect from one entity to another. So if I'm mapping, we call this in our terminology we call that as a mapping. So no need to worry, or don't get confused regarding that. What do you mean by map? Mapping is like I'm connecting with one entity to another with using a lines. Okay, so I'm just connecting. So how I'm connecting? In different manners. So what are those manners? They are something like one to one, one to many, many to one, and many to many. So like this we have different mapping cardinalities. Okay, so we have different mapping cardinalities that is make us to associate with other entity. So it is a relation between the one entity to another entity. So it is going to give me a logical definition that why it has been connected and how it has been connected. So it can be from one to many, one to many, and many to many, and many to many. Okay, so how it can be? Say suppose I have something like, now here if I say 1 and if I say 1, that means this entity is 1 to 1. That means one student joined one college. Now this is 1 to 1 relationship. Now suppose here if I say 1 to m. So if I say 1 to m. So if I make this as an m, then one student joins many colleges. It's like he wants to join, like in those application, he wants to put the applications in many colleges. So he's going to put many colleges the applications. So he wants to study and he wants to get any one college. So I wants to apply many colleges. So student is applying. So here in the relationship will be going to change. So here I will say apply. I will say here apply. So student apply many colleges. So here I will be saying 1 and m. So when I'm saying 1 and m, then it is 1 to many. Okay, then what about the many to 1? So when I'm saying many to 1, so if this is like this. So if I say here colleges, one student do many courses. This is also 1 to many. But when I'm saying many to 1, so how we can give the example of many to 1? Can anybody tell? Many to 1 example is roll number existing in the all the different sections. So if it's a college, I will be saying something like a student roll number is an entity which is going to get another entity like department. So student is connected to examination department, student is connected to another department, examination department, student is connected to another department. So all the departments, so many departments has been connected to one entity. Okay, so many department has been connected to one entity. So many to many, many to one. Now I'll be saying something called many to many. So I'll be saying here many to many. So how I'll be doing this one? So I'll be saying m to n. So I'll be saying m to n. So many students join many courses, many colleges. Okay. So I can take any examples like this. So we'll be having the different mapping cardinality when I'm writing that down. This will be the scenario. This scenario will be the same. This will be the same, and this will be the same. But while writing this particular one, whether it's a relationship, when you're talking about the relationship, then there will be mentioned that this is one to one or many to one or many to many. Then if you write, then that entire schema, that is the entire ER diagram will be changed. So the concept will be changed depending upon the writing of the relationship. So this is how you're going to write the relationship. So one to one, many to many, or many to one, or one to many. Now, how the relationship model will be there? So the relationship model will be in our Rdbms. Relationship model will be like this. It can be said as a model is based on the first order and define the table in a n array relation. So it will be having n array relation. Now what is this relation? That means n number of records we will be having. Suppose I said SSID, as I say, roll number, name of the student, student age, student's classroom, which section he belongs, like this. These are all our attributes. So these are all our attributes. Okay, so how I'm representing the attributes here, I've been representing my attributes in this fashion. So if you see the attributes, so attributes were representing in a diagram in this fashion. So here I have written roll number and name. So these are the different attributes. So how it is being stored in the relation database? In the relation database, it will be stored in this form of tables. Then coming over here, now this all things are called as a tuple. So this is one. So in our terminology, we call this entire thing as a tuple. So here it has been 104, Bob 149A. Now this is called as a tuple. We call in our another way as a rows also, rows. Okay, we call this as a rows, or we call this as a record. We call this also once in called record also. We're going to say we call record, right? Now this part we call as a column. Okay, we call this as a column. Then from one to this particular, that means entire record, this entire table has some relationship. How it is a relationship? We have something called name is there, roll number is there, age is there. It has some data which is saying that there are some relationship between each and every attribute. Okay, now how it I can say relation? The data stored in a table are called relations. So these all the data, whatever the data you are saying, these all are relation. So because these are all our relations. Relations can be normalized. That means you want to segregate. So suppose here this is there. Now this belongs to a student's profile up to this. Now this is belongs to a class. So I can separate and I can link that. So that will going to come in the normalization. We will see in the upcoming classes. Okay. Normalized relation values saved in a atomic values. So as I told you in yesterday's class, that is acid properties. So did you know about this acid properties? So if you are known about this, then you may have no problem over here. If you forgot this, again I'll be telling you. So we have in Rdbms in the relationship, we have something called acid property. We have something called acid properties. So what is this acid properties? We're going to say A means atomicity, C means consistency, I means isolation, D means durability. So we have four types of relation models. In that we have something called acid properties. Now what is this acid property? We're going to say, take the example of your nowadays you are paying the amount using your Google Pay, Paytm or something like that. So what you are doing over there, I want to pay the amount to my friend. So when I want to pay the amount to my friend, what I'll do, I'll use the Google Pay and I'll type his mobile number and I'll try to pay it. Now, whether the amount has been deposited in your account, in his account, or whether it has been debited from you from your account and it has been credited in his account, how I'll be knowing? I'll going to get a message. So the message will be saying that it has been success or it has been got failed due to some connection, whether there is no balance in your account, something like that. That means it will going to state me the information that whether it is success or failure. So success is amount has been debited from your account, it has been credited in your friends. Failure means the amount has been debited, but it has been not credited. Otherwise, the amount has been not debited from your account, but you will be saying that due to some technical reason, it has been not the further process. That means either it is failed or pass. It will going to inform me the information. The atomicity is that one, saying the status of your content, the transaction. Then when I'm going for the consistency. Now consistency is what? Here I will pay the amount. Now I have the amount in my account. In my account there is something called 5,000. Now that amount has been transferred to my friend, say 2,000 I have transferred. So when I transfer to my friend, at the same time, once it has been debited from my account, it should update that the amount has been debited from your account and the amount is left over in your account is 3,000. At the same time, in my friend's account, the amount whichever the current balance is there, to that the whatever the amount has been credited, it should be deposited and it should be give the status of what is the total amount right now he is existing. That means here the consistency means it should keep track of your previous data and the after data also. Okay, if that is not maintained, then there is no use of consistency. So your probably that is whether it has been uh, deposit or it has been credited, withdraw, whatever it is. So it should be preserved your previous value. Okay, it should be preserve your previous value. So I is isolation. So here the isolation is saying is that the same above the above same statement. So where you are trying to say that the statement as atomicity is saying that whether it is failed or success, then C is the consistency in saying that it is maintaining the what is the previous statement and the current statement. Okay, then isolation, it will not, it will be checking all the data whatever that has been transacted, whether it is perfectly done or not. Okay, then once the all things has been finished, whatever the transaction has been done, these are all our atomicity, consistency, isolations are temporary base. That means the amount has been given the status, but durability is time. That means up to date the time. Once the transaction is been completed, it should be saved in your data. That means commit. That means the transaction should be completed or the transaction should be any status, it should be confirm me and it should be saved. That means once the amount has been detected, it should be say the status that amount has been detected. Now if you want to do any transactions, so right now your transaction leftover amount is 3,000. It should not say that 5,000 is there, in that 2,000 has been detected and 3,000 is left out. That is not the status. I want the confirmation 100%, it should be saved. That means amount whichever that has been detected, it should be replaced with the original value and permanently it should be stored. So that is durability. So like this we have the acid properties. Based upon that we will be finding. Now whenever you try to find it, in each row relation contains a unique value. Now here if you see the above one, here we are been maintaining the unique value. Now this is what you have to check it. So uniqueness, that means whatever the data I am trying to store in my database, I should have any one column uniqueness, so that it will be for my future reference, it will be very easy to pick up the data. If I don't maintain the uniqueness, then it is very difficult for me to trace. Like suppose Alex or Maya is the same name, I can have the same name with these two people, but if I want to trace or segregate the people or identify one, then I have to give any number which is going to say that this is different and this is different. So you have to maintain the unique row. So it says that in our database, all the rows whichever you are related, that contains one unique value. Each column in the relation contains values from a same domain. That means here what is it saying? A column in a relation. So what is the column in a relation? So this is a column in a relation. This is a column in a relation. This is a column in a relation. This is a common relation. Like this, we have different columns. Each has each relation. Now what we have called like this one, we call this as a domain. So this we call as a tuple. This we call as a domain. So this data whichever you are taking, this is from the same table, or it has been not picked up from somewhere. So if I'm taking 14, 14 is from this particular table, and this is coming from this particular column. So same domain. It is not from other part. Okay, so when I'm saying 10, so 10 is from here, so from the class, not from some other thing. So 10th class. So I'm saying section A. So section A is from this particular. So from among these, A is pickup, which is can be a the ninth class, or it can be a ninth class, or it can be a ninth class. Okay, anything like that. So A is belongs to ninth class, B is belongs to 10th class. Like this, that it has been taken the content or the record from the same column or the from the domain. So whichever the data you are picking, it is from this particular table, not from any other domain. Okay. Yeah. Next, we'll see about the schemas. So what do you mean by schema? So schema is a skeleton. Schema is a skeleton structure which is going to tell me about the logical view of the entire database. So as which I told you in the previous class. So it's a skeleton which is going to tell me about the logical view of the entire database. So it is saying that how you are going to organize the data, how you're going to relate it, and that are being associated with one another. So you, in order to tell that whatever the data you have been gathered, that data has some relation, it has some structure, and the data that has been storing in that particular database are interlinked to each other, for which you are writing some rules, set of rules. Now here, for set of rules in our terminology, we call this as a constraints. So it formulas all the constraints that are applied to the data. So to that data, I am putting some restrictions. Now if you see the above table, above relation diagram, here we have seen that I am trying to put that I will not allow the person if I don't have the same duplicate number. So if I have duplicate number, I will not going to add it. So if I say 101 or 1101, this number I don't want to add again because this is unique. So I am putting some restriction. Okay, I am putting the restriction that this number should not be allowed. That means once it has been allotted to that person, so it should not be. That means I am putting some restrictions. So here it constraints means restrictions. Constraint means restriction. So schema is a skeleton which is going to represent a logical view for the entire database. And how the data is defined? It is organized and it has been relation among the associated. That means it is going to say that there is a relation. So I told you that one among the other data is depend on one other data. So with some constraints. Now, when I say data schema, how I'll be going to do? I'll be saying about the entities, wherever you find the entities, wherever you find the relationship among them. Now that is what we call as a schema. Entity and the relationship. So you have to find the entity and the relationship that says the data schema. Okay. So a data schema is defines the entity. So wherever you find the entities and the relationship among them, then that we call as a data schema, database schema. Now, what is this schema will going to have? This schema is going to have the descriptive details of the database. So it is going to give the full data of the database. That is what I told you. No? It will go and tell about the structure. So skeleton, it is a skeleton. It has the entire view. That means what is that? What it contains, everything. So that means it will give the full details of that, which means along with the diagrams. So it is going to show with, that means if I see that particular diagram, I can able to get the entire information of what he wants to explain about that particular concept. So with that particular thing, I can able to know how the how to use the software. So here it will be saying that I can use that. That means with this particular picture, I can able to identify, okay, this is the schema. With the help of that, I can make the table. So in order to make the use of software, so if I want to use the software, that MySQL or Oracle or Ingress or DB2, so whichever the software that I want to use to maintain the database, I need some pictorial diagram. Okay, I should have some sketch. So seeing that particular sketch as a programmer, I can understand and I can build the database. Okay, so we call that as a schema diagrams. So what the schema diagram will going to tell you? It will give the details of the database. It is going to give me the full details of the database. So what the database is having? It is having some entities and relationship, which is going to say the data schema. Based upon that particular diagram, as a programmer, I can understand how to make the database. So we'll see the one example over here. I have something called a view and view2 and view3, like this. I have some n number of views. In that, one view is something called student. Now this is a student and this is a diagram. Now this is tell about the schema, logical schema. So it is going to tell me about the logical schema. Now this is about the logical schema. Okay, now what is the student? Now student is the entity. Now in our diagram, if you see the previous say, I have given the entity. Now this is the entity, student id, student name, project id. Now what are these are attributes of this particular student. So this is the relationship. So student and attributes I have. So I have a logical schema. So it is saying, okay, there is something like this. So seeing this, okay, I have to, as a program, I have to understand, okay, I have to create the table name as a student, and it has some columns called student id, student name, project. So I will take the help of the software, and if I, whichever software I'll take this as a diagram, as a photo proof, and I'll be trying to develop one table, a database. So if I want to develop a database, I should see this. Okay, seeing this particular thing, I can able to understand, I can say trace out, okay, this diagram is called as an entity, this we call an attribute. So combination of attributes, and this is called as a table, attribute and entity called as a table. So I'll be going to create a table with my software. Okay, so this is logical schema. Now seeing this logical, so now this is how we call the logical schema, because this is totally depend on the diagram. So seeing the diagrammatically how it has been linked. Now coming to the physical schema that I want to convert using the software, I want to convert this everything into the software. Okay, so here you will find the physical schema. So physical schema will be looking like this. Okay, so here we will be having two parts. So it has been categorized into two parts. So what are those? One is physical schema, another is a logical schema. So it contains the actual storage of data. So it will going to have the storage of data, and from a storage like files, indices, etc. And it is defined how the data will be stored in the secondary storage. So how I can be stored that, see whatever the data I collected. So I can see this, I can view this. With the help of this software, I can convert this physical schema into my software. So in the secondary storage is my hard disk. So I'm going to store my data into a hard disk. Seeing this particular files or seeing this particular content, the physical schema, I'll be trying to see this. Now coming to the logical schema, this schema defines the logical constraints. So it is having some rules. Here I have some rules. So with the help of some rules, I need to apply to the data storage. It defines tables, views, integrity constraints. So it is going to define the tables, it's going to define the views, where it is going to say that, okay, I have to check it. So with the help of this, I'll be extract the data and it will convert it into hard disk. Okay, now here the schema will be in a form of tables or a view. Seeing this, I can put it. So here I'll be having some restrictions on the files. I may not have the restrictions, I will be having the data only. Now here I will be having the restrictions. So checking the constraints, rules and regulations, and follow according to that, I'll be storing into my database. So this is how I'll be using. Now when I'm saying schema, the schema will go into tell about the instance. So what is this instance? It's it is an important to distinguish two terms individually. What is that? A schema, which is the skeleton of the database, and it is designed when the database does not exist at all. So this is what you have to remember. When the database is not exist, then only I'll go with the database schema. Once the database is operational, that means it is ready, it is very difficult to make any changes. A database schema does not contain any data or the information. It doesn't contain any information. You have to remember why, because I told you that it is a skeleton. So skeleton doesn't have anything. It's a just model. Okay. So it is having a data like a skeleton, the structure will be there. So it is ready to operation. So what kind of operations it's ready? Because now I can store the data. So if you think that I can store the data, then it is ready. So a skeleton, we are creating an empty structure. So the empty structure we are going to create, that is what we call the database schema. Okay, it will not doesn't have any information. Now when I'm telling about the database instance, is a state of operational database with the data at any given time. That means it is ready. So here this is empty. Now when I'm saying database instance, it is operational. That means I am ready to insert the data. at whichever time I like it. So whenever I have find the time or I can have it, I can put the data into that. Now this is without any data. Now this is with data. So it contains the database. So instance is a day-to-day time to change. That means it will be going on change, because today I added the data, tomorrow I have, like as given the previous the example of Paytm or Google Pay, I have withdraw the amount, I deposit the amount, I transact the amount. So this is what happens. That means it is something it is having. So the account is having some amount. You are trying to do operational. So operational is that one. So doing some transactions on that. So whenever at whichever time you want, you can able to do it. So when it is happens, if the table is consisting data, then only I can put the operational. So such database we call as a database instance. We call that as a database instance. Okay. Now, coming to the database independence. Now what is this database independence? A database independence contains a lot of data in addition to the user's data. See, I am adding the data. That is my data. Apart from that, I have some extra data for which I'll be make it called as a database independence. So how it will be, for an example, if I stores a data about anything, okay, then I want to retrieve it and I want to locate it. If I want to do such kind of things, it is very difficult to modify or update some data once it is stored in the database. But as a Rdbms, if I expand it, needs to change over a time to satisfy the requirement of the user. So if the entire data is dependent, then it can become a tedious and highly complex job. Now I'll be explaining this with an example. Now what is happening over here? I want the data, no additional data. So database system normally contains a lot of data in addition to the user data. Now user data is say something like I am having something called roll number, name, and address, like this I have. Apart from that, database is going to make one record a one key or some column, extra columns will be added, which is not visible to the users. One or two or three columns it will be added extra. In that it is having some additional data apart from the user. My data is like I want to store your name, your address, your contact number, something like that. It's my intention to store your data. But apart from that, the system will going to maintain a separate columns to the existing one. In future, suppose something has happened to my database, I can retrieve with that particular place. So this can be done with the database administrator. So if I want to store the data, any data, and I want to locate it where it is, and I want to retrieve that, means I want to select that. So if this is very easy for me to do that. But if I want to modify, if I want to do changes, or if I want to delete that, once it has been stored in the table, so that means in the database permanently I store it. Now I want to modify. Now when I want to modify, it is very difficult for me, because locating is okay, retrieving is okay, but modifying is very difficult for me, because as I told you that it has been expanded. And sometime my requirements are been changing. Then what is happening if the data is dependent? It should be independent. So I should in a position that the data should be independent. If it is dependent, that means it's depend on so and so only. If it is content, the content is only on that particular thing, then I cannot modify it, because it's dependent. I should have the flexibility to modify it. If I don't have flexible to modify, then it is very difficult. So that is that table we call, that database we call the independent database. So here we will be having the in data independence like this. One is logical and the physical schema. So as a previous diagram you have shown, I shown you the previous one, the previous diagram if you see. So here you can find the physical schema and logical schema. Now if you see this, you can able to identify that the top one is the logical data independence and down one is the physical data independence. Okay, so how will happen in the logical database independence? It stores the information about how the data is managed inside. Logical data will say that I store the information and it will going to manage inside. How the manage, it will going to tell. That is the logical example. A table relation is stored in the database and it has some constraints or some rules applied on that relation. So what is logical says, already I told, I put some constraints. So if I put the constraints, it's my own constraints. Okay, saying that roll number is compulsory, it is mandatory. Okay, and I cannot keep blank. That means I cannot omit. That means the student should be allotted roll number. This is the rule I am doing. Now that means some logic you are telling about. So there is some hidden logic according to why I am putting the restriction, because in future with that roll number I can do lot of things. I can manage the data in lot of way. So that's why it is a logical independence. Okay, it's a mechanism. So it is an independent. That's why we call it as an independence. It's a mechanism. Okay, it will liberate itself. It is going to liberate itself from actual data storage on the disk. If we do some changes on the table format, it should not change the data residing on the disk. So it should. So whatever I'm doing the changes to the table format, it should not change the data on the disk. So in some particular location, my data is there. It should not replace that. Okay, you should be save the data in such a way that it should be not replace the location of the disk. Well, it should be saved. Now when I'm saying about the physical data, here all the schemas are logical and all the actual data is stored in a big format of the disk. Now when I'm going for the physical data, is a power to change the physical data without impacting the schema or the logical data. That means you are trying to change it. So I want to change the data, but it should not modify the logical data. So as I'm telling that it should not modify the logical data. Now how it will happen? For an example, if you want to change or upgrade the storage system, suppose you want to replace hard disk with SSD, it should not have any impact on the logical data or the schema. That means I'm trying to remove the hard disk, or I want to upgrade with my new hard disk. Nowadays we are getting an SSD hard disk, okay, comparing to the old hard disk. So when I'm putting that, it should not be impact on my logical. That means whatever the connections, that means the cable wires or whatever you are connecting, it should not be mismatched. That means if I remove the hard disk and replace with a new hard disk, it should be flexible. Okay, it should be the component with the cable wires and all things what is there in the old design should be compatible with the new one. Okay, it should not like, okay, you are changing the hard disk, throw the entire computer because hard disk is not supporting the cable wires and all that. So throw your device and you purchase a new computer. It's not like that. Okay, like that, the logical data or the schema, the model that is there should not be disturbed. So if you are doing any kind of replacement, see that the architecture should not be different. Okay, so this is how the today's class. So any doubts, you can just raise the questions in the chat box. Then we will be having the end of the class. Yeah, any doubt?